This is a demonstration video showing how to make a simple lead-acid battery, and in comparison we're going to also have a look what's inside a commercial car battery. In our homemade lead-acid battery, we're going to make a battery consisting of 3 lead-acid cells. These are going to consist of 3 glass jars, and the electrodes are going to be made from some plumbing solder. The plumbing solder is cut into 4 pieces, 2 long pieces which are folded over to connect 2 jars together, and 2 shorter pieces which provide the end terminals. This is hopefully shown in the above diagram. We now add sulfuric acid to our glass cells. The sulfuric acid, by the way, we harvested from a car lead acid battery. The chemical reaction within a lead acid cell involves a negative plate consisting of lead metal and a positive plate consisting of lead oxide. The sulfuric acid electrolyte allows these plates to exchange ions in the form of lead sulfate, and the electrons, which is where we get our current flow from the battery or cell, around the outside. The overall chemical reaction can occur in both directions. One direction is discharging, the other direction is when the cell is charged by an external current. If we try to measure the voltage across our battery, initially we get 0 volts, and we get 0 volts between the cells. This is because there is no driving force within the battery to generate any flow of electrons. To give the battery some potential, we now charge the battery using a power supply. On charging the battery initially, we will be generating hydrogen at the negative electrode and oxygen at the positive electrode. The oxygen will react with the lead and form lead oxide, which is what we want for our lead acid battery. When we look at our cells close up, we see a lot of gas being produced on our negative electrode. This is of course hydrogen, and on the positive electrode we hardly see any gas being produced at all. This is because the oxygen which is being produced is reacting with the lead, as we said earlier, and forming lead oxide. After charging the battery for about 45 minutes from a power supply, we now disconnect the terminals. We can now apply a voltmeter and we can see the voltage across the battery. In a lead acid battery, each cell gives just over 2 volts, so therefore within the 3 cells we're getting about 6 volts, which is what we're reading on our voltmeter. After dimming the lights, we've connected an LED to our battery, and we can successfully see that our battery is powering our LED. When we remove the lead wire connecting 2 cells together, we can see that one side is quite shiny and the other side is dark. This is because one side is lead metal and the other side has a coating of lead oxide. In the second part of this video, we're going to have a look inside a commercial lead acid battery. In this used lead acid battery, the electrolyte has been drained and the top has been hacksawed off, and what is clearly visible are 6 independent compartments. The cells are connected together by bars of lead which then connect to the terminals of the battery. This particular car battery is actually 6 years old, has lasted very well, especially considering the abuse it has been given, so it'll be very interesting to see how it's failed. On removing the plates from the first cell, it is quite apparent that the positive plates have degraded somewhat. However, the negative plates, the lead, appears to be reasonably intact. It is only the lead oxide which appears to have degraded. It is worth noting that the lead oxide plates and the lead plates are separated by a membrane, otherwise they would short out. When we start dismantling the battery towards the central cells, both plates, the lead oxide and the lead, appear to be reasonably intact. If anybody knows why this might be, when you compare this with the outer cells, I'd love to know. I hope you found this interesting. Thanks for watching.